Greetings, ladies and gentlemen. Now, in the previous video, we went over the direct comparison test. Well, sometimes the direct comparison test can fail. All right, in other words, if your series is not smaller than a convergent and it doesn't converge, or the other way around, then the test would fail. All right. If you don't know what I'm talking about, take a look at our video about the direct comparison test. Now, the limit comparison test is the other type of comparison test. And all that this says is that the limit as n approaches infinity of a sub n over b sub n being the series that we are comparing it to, has to equal L, where L is a number that is positive and finite. Okay? Now, if L is positive and finite, both series behave the same. Okay, so what I mean by both series behave the same is that if b sub n is divergent, then a sub n will also diverge. Same way, if b sub n converges, then a sub n would also be a convergent series. Let's jump into some examples right here. If we have, let's see, sigma 1 over the square root of n plus 7, and let's see, okay, 1 over the square root of n plus 7. First test to use, always, the nth term test for divergence. That test would fail in this case, okay? If you don't know why, take a look at our video for nth term test, and you can easily figure out why. And so that test fails. The next test that we can use is the direct comparison test, all right? But let's just step aside from the direct comparison and go straight to the limit comparison test, all right? So what can we compare this series to? Let's compare this to 1 over sigma 1 over the square root of n. Why the square root of n? Well, the square root of n, well, we look at whatever term has the most power in both the numerator and the denominator. In the numerator, all that we have is 1. In the denominator, all that we have is the square root of n. Okay? Or excuse me, we have the square root of n plus 7, but square root of n is a variable term. In other words, it can change. 7 is simply a constant, so let's not even worry about that. All right? Now, this is equal to 1 over n to the 1/2. Whoa, all of a sudden this looks like a p-series. Okay, now p-series, if our p-value is between 0 and 1, then we have a divergent p-series. Therefore, by the p-series test, this is b sub n is a divergent p-series. Okay, b sub n is a divergent p-series. Now that we have our a sub n, this being our a sub n, this is our a sub n, and this being our b sub n, we can take the limit as n approaches infinity. All right. So we can say the limit n approaches infinity of 1 over the square root of n plus 7 divided by 1 over the square root of n. All right. Now dividing fraction is the same as multiplying by the reciprocal, thereby getting limit as n approaches infinity, the square root of n over the square root of n plus 7. All I did was simply multiply this, or flip this around and multiply this term by the reciprocal. Okay. Now, using, well, when you substitute infinity into there, we'll get infinity over infinity, which is an indeterminate form. If we get infinity over infinity, that is L'Hopital's, that is the first indeterminate form that L'Hopital talks about in his rules. And if you don't know what I'm talking about, send us a message and we'll make a video explaining L'Hopital's rules. But using L'Hopital's rules, rule number 1, we can take the derivative of the top, the derivative of the bottom, and we can realize that we get the limit as n approaches infinity of 1 over 1, which is simply 1. Now, 1 is equal to our L right there. If L is positive and finite, both series behave the same way. This L is 1. 1 is both positive and it is finite. Therefore, a sub n will have the same behavior as b sub n. B sub n is divergent. Therefore, a sub n will also be a divergent series. Okay, keep in mind that this number has to be both positive and finite. Now let's go on to another example. All right, let's say we have sigma n equals 1 to infinity 3n over n squared plus n plus 1. What can we compare this to? Okay. Now, in our video about the direct comparison test, I went a little bit deeper into why we should compare our series with certain terms. But if you want to get a better idea, I would recommend a better idea of how we find out our B7, take a look at our direct comparison video. But in this case, again, 3n is the only term on the top, so therefore automatically it is the most powerful. In the denominator, what is the most powerful term? Well, we can say that between n squared and n1, n squared is the one that rises or increases the fastest because it's something squared. So that's what we'll put, 3n over n squared. Well, we can simplify this down into saying 3 over n, which all of a sudden is a harmonic series. Now, harmonic series is always divergent. Therefore, our B sub n is a divergent series. All right? Now, we take our original series, the limit, n approaches infinity, 3n over n squared plus n plus 1 divided by 3 over n. This can be simplified down into saying the limit as n approaches infinity of 3n over n squared plus n plus 1 times the reciprocal of this, which would simply be n over 3. Okay? Now, I'm just going to put the parentheses. By the way, if you look at this, we can see that this 3 and this 3 cancel out. So now we get the limit n approaches infinity of n times n gives us n squared divided by n squared plus n plus 1. Okay, substitute infinity, we get infinity over infinity. Now, so if we take L'Hopital's rule a couple of times, we'll eventually end up getting 1 as our final answer in this case as well. Now, we got 1 as our answer in the previous example. Now, our answer doesn't always have to be 1 for L. Okay, now this is equal to L. Our answer for L always doesn't have to be 1. It simply has to be positive and finite. It was simply a coincidence that we got 1 both times. Now, L is both positive and finite. 1 is both positive and finite, therefore both series behave the same way. Our B sub n series is divergent. Therefore, our original series, or we'll call this our A sub n series, is also a divergent series. Both behave the same way. Okay. Now this concludes our video for the limit comparison test. If you have any questions at all, please send us a message on our Facebook page.